Dimension is another way of talking about a measurement or the size of something. And what we're saying here is that the dimensions, both of them, of cylinder A are doubled. So I've done a little sketch of cylinder A there, and we're now going to turn that into prism B because a cylinder is essentially a prism, and we're going to double things. Now, I'm not going to draw it perfectly accurately, but you'll get the idea. The point is that what I need to do is take this height of 5, and I need to turn that into 10. So the thing has gotten taller, but also it has gotten wider, and instead of the 4 that it was over there, my diameter now needs to work to be 8 centimeters. And in that way, I've now doubled the dimensions, and I'm going to do a couple of tests to see what happens to the surface area and the volume if I do that doubling on both of the dimensions. Okay, reminder, surface area of the cylinder is going to equal 2 of the circles, so 2 pi r squared, plus the wraparound bit, 2 pi RH. Okay, so that is going to be 2 pi, and the radius, careful, it's not 4, the radius is half of the diameter, so that is 2 squared, plus 2 times pi times 2, and what's the height? The 5. Okay. All right, when I type that into the calculator, I'm going to leave it in pi for now, and I'm going to show you why. This is quite a maths core concept, but the actual working out is very straightforward with substitution, which is also a maths lit skill. Okay, so now I'm going to have 28 pi. And normally I would say to you, if we were not testing ratio, which if you've looked at what's coming next, it's going to be that, then I would say go and work it out and get it into decimal. Okay, my unit is centimeters squared, but I'm going to make a comment here, and I want you to leave the pi, okay, because we are going to put it into a ratio. And when you put things in a ratio, you're putting them in fractions. And fractions means that things cancel, okay? So do not convert to decimal at this point. Right, now we want to calculate the surface area of B. So I want to remind you that everything that I've got in my calculations for A is just going to double, but obviously not the pi. That's not actually one of the measurements. It's just part of the thing that I multiply the measurements by. So this is going to be 2 pi, and instead of the 2 for the radius, I now have 4 squared. And here where I've got 2 pi RH, my R is now 4, and my H is now 10. Okay, when I get those into the calculator, I end up with 32 pi plus 80 pi. Right, so that gives me 112 pi, and I'm going to put my units back, which is centimeters squared. Okay, now we're going to see what happens when we put these guys in a ratio together. We've got to take the ratio of the surface area of B over the surface area of A. Okay, so that was 112 pi over the first answer, which was 28 pi. Type that into your calculator and see what you get out. I'm going to suggest that the pi's will cancel, and that'll happen on your calculator anyway. And then basically all you're doing is you're saying 112 over 28. Now, if you had done the rounding off, you would have ended up with something not quite accurate. So for these questions, when we're talking about the relationship between surface area, volume, doubling, and so on, then you must leave everything in pi. Okay, so that's going to give us 4, which means if you double things, so I want you to just get your head around that, when you double things, the measurements, you end up with 4 times the surface area. Interesting. And that's what they're going to ask us in the next question. What do you notice? Okay, so I'm going to put this in a full sentence now. I'm going to say when the measurements or the dimensions, right, of A are doubled to get B, the surface area becomes quadrupled. Isn't that a lovely word? And that means times by 4. Okay, what's interesting is doubled is times by 2, and now we're talking about something timesing by 4. Okay, hold that thought for a moment and let's look at the volume. Okay, volume is always easier to calculate, isn't it? Okay, so volume of A, my volume is going to equal pi times r squared times h, right? And r was 2 for the first one, and h was 5. Okay, that's going to give me 20 pi centimeters cubed. For B, it's everything the same excepting doubling those dimensions. Pi r squared is now pi times 4 squared, and the 5 is now 10. And that gives me not 40 pi. It didn't double. It's 160 pi. That is so much more. You know why? We're squaring the 4. It really makes a big difference. And it's the same as those conversions we were doing at the beginning of the section. The minute you're dealing with volume and you make slight changes, you're dealing with changes that are cubic or higher, okay, as you'll see now. Now if I do this ratio, look what happens. I end up with 160 pi over 20 pi. Those will cancel. Can you see the answer? 160 over 20, it's 8. So you double the measurements and you end up with something that is 8 times. That is so much bigger. So our comment here is I'm going to say that B's volume equals 8 times A's volume. Okay, now what we want to know is what's the relationship between the surface area and the volume if the dimensions are doubled. Okay, so let's look at surface area. Okay, when you double the dimensions, the surface area multiplies by 4, which is the same as multiplying by 2 squared, right? When you double the volume multiplies by 8 or multiplies by 2 to the 3. Isn't that interesting? I want you to note something. It multiplies by 2 to the 2 when you're dealing with centimeters squared. And it multiplies by 2 to the 3 when you're dealing with centimeters cubed. There's definitely something at work there in those patterns. So what we're seeing is that when you double something and you double all of its dimensions, it does a whole lot more than double the volume in the surface area.